In this problem, we are asked to find the amplitude, the period, and the phase shift, and to sketch the graph of the function y is equal to the opposite of 2, sine of 2x minus pi plus 3. We will first look at the function, the opposite of 2, sine of 2x minus 3, knowing that the plus 3 is going to shift the graph up 3 units. That means it would not change the amplitude, the period, or the phase shift. It would just change the y values by moving them up 3 units or affecting the range. In order to solve this problem, we will first recognize that our amplitude would be equal to 2 because our amplitude is given by the absolute value of a, or the absolute value of a negative 2, which is 2. This means from that average center point, our maximum deviation above that center would be 2 units, and below that would be 2 units. If we look at our period, we will recognize that our period is given by 2 pi over b, which is equal to 2 pi over 2, which gives us pi units. Our one cycle interval would go over a total of pi units. Finally, we will look at our phase shift, and our phase shift is given by the opposite of c over b, where c is a negative pi and b is 2. Therefore, our phase shift is a positive pi over 2 units. We can verify that with finding our one cycle interval for our sine function by placing 2x minus pi into the equality between 0 and 2 pi. If I add pi to both sides and divide by 2, I will get x between pi over 2 and 3 pi over 2. Indeed, we have a pi unit interval with our phase shift being pi over 2 units. We are now ready to sketch the graph y equal to a negative 2 sine of 2x minus pi, plotting the 5 critical points, and then we will shift it up by 3 units. On my interval, between 0 and 3 pi over 2, I know that my sine function takes on its average value, in this case x equal to 0, at the start and stop of the interval. I also know that halfway between that interval it will hit its other average value. I also know that halfway between pi over 2 and pi, my sine function without that vertical shift would first hit its minimum value at a negative 2. I know that it would hit a minimum value because a is negative, meaning it decreases then increases. I also know that halfway between the average values, it's going to take on its maximum value, which is a positive 2. Now that I have those 5 critical points, I am ready to sketch the graph by shifting those points up 3 units. Therefore, each one of my average values, or my x-intercepts, would move up 3 units, giving us an average value for the function of 3. Our minimum value would also shift up 3 units, giving us a new minimum value of a positive 1, and our maximum value that was at 2 is now going to shift up to 5, or shift up 3 units. And now I'm ready to sketch my one cycle interval, knowing that this function would repeat itself. Again, we now can see that the range of this function has been shifted up, going from positive 1 to 5. We also recognize that our average value is given by 3, or moving it up 3 units, giving us our graph.